Hey students, today is Tuesday, March the 9th, and we will be discussing Unit 6, Lesson 7, which is making connections to decimal notation. So we're just continuing on with our understanding decimal notations unit that we started a week or so ago. All right, so on our next slide is our multiplication table is there as a resource for you, and the next two slides are places where you can insert a picture of your work so that your teacher can see your work. That's if you're working in your math binder or if you're completing your work in your notebook. In order for your teacher to see your work, take a picture of it and then insert it into one of these slides. Our learning target for today, I can use equivalent fractions to add two fractions with denominators of 10 and 100. Our central questions for this unit remains the same. We're just continuing to build upon it. How does the place of the digit within the base 10 system affect the value of the digit across the decimal point? And also, what is the relationship between fractions and decimals? Notice and wonder. Now, in this next activity, you have a choice. You can complete it within the binder on page number 35, or I've included it in the next four slides coming up. So I've got it in the next four slides coming up, or page 35 in the binder. So what we're going to do is take a look at this slide and the fractions that are being added on here. And then we go on our next slide, we're going to complete notice and wonder. So go ahead and take a look at this particular slide. And what I want you to do, if you're at home and you're not on our live session, go ahead and look at it, take a note of it, and I want you to write at least one thing that you notice and at least one thing that you wonder. And you're going to type that on the next slide. So see here, you got 4/10 plus 33 hundredths equals 73 hundredths. And right below that, we've got 40 hundredths plus 33 hundredths equals 73 hundredths. So pause the video and just be thinking about at least one thing that you notice and one thing that you wonder. Okay, so you've had a chance to look at these equations and consider at least one thing that you notice and one thing that you wonder about it. So I'm going to go to the next slide. These are just some things that you could have written about them. So for I notice, you could have noticed that 3300 was added in both of those equations. So 3300 was added in both of those equations. And also, both equations had the same answers. They had the same answers. So one thing that you could have put for I wonder is, well, how did they have the same answers if 3300 was added to two different fractions? So how did that become the case? So those are just some things that you could have noticed and could have wondered. All right, so we're just going to continue on to our next slide. So here we're going to use models to just help us to understand how 4/10 plus 33 hundredths equals 73 hundredths, and also how 40 hundredths and 33 hundredths equals 73 hundredths. All right, so for this one, you see 4/10 we've got it shaded in right there, and we got one of the tenths shaded in. I'm sorry, 4/10 we got four of the tenths shaded in here. Let me go ahead and make sure I get the rest of these in. And we'll go to the paint bucket. Okay, so we got 4/10 shaded in here. And on the hundredths grid, we've got 10, 20, 33 shaded in there. So if we were to combine these, if I was to take these and put them over here, or if I was to take these 4/10 and I put them over here, you'd be able to count 7 of the tenths filled in, which would be 70, and you'd see 3 of the units filled in. So that would be 73. Now, let's go to our next slide. This is 40 hundredths and 33 hundredths. So 40 hundredths and 33 hundredths. So the only thing I did was just taking the tenths grid and we just partitioned it into a hundredths grid. We can do that because it can be equivalent. So if you can see the 40/10 and the 4/10, they take up the same amount of shaded area. they are equivalent to each other. That's why the answer was the same for both of the equations. Remember, you can pause this video as often as you like. All right, so moving on to our next slide, guys. So we're going to look at another visual model here to show you 4/10 is equal to 4/10. So I've got the fraction model and I've got the decimal model on this side. So this is the decimal model, this is the fraction model. They are equivalent to each other. And on the number line that we completed last week, we showed the same thing on our number line that we built in our notebooks. So 4/10 in the fraction form is equivalent to 4/10 in the decimal form, just like 3300s in the fraction form is equivalent to 3300s in the decimal form. And we're going to go on to our next slide. How could we turn this into hundreds? So this is our tenths grid that we have here. This is our tenths grid. How can we turn that into hundreds? Well, all we needed, we've got the different columns. Originally we had the columns in there, and now 10 columns, and now we added lines to represent 10 different rows. So now there's 100. So there's 10 in each column, and that there's 10 in each row. So that equals 100. All right, students, so on our next slide, I've got a short video, 3 minutes and 37 seconds. This is slide number 14, adding fractions with denominators 10 and 100. And I'm going to want you to watch this independently. It's about 3 minutes and 37 seconds. Again, I want you to pause my video and go to that slide and watch this video. All right, so we're going to go to our next slide. And we've got the same equations here. Just some things I want you to be thinking about as we continue to work. And we've already done our notice and wonder for this. What is similar about these two equations? So this is considered one equation, and this one is another equation. What is similar about these equations? What's different about them? How are the two fractions related? And how can the fraction with the denominator of 10 be modeled to show an equivalent fraction with the denominator of 100? So how can this fraction be shown to show an equivalent fraction with a denominator of 100? And if you think back to our previous video where we went from the tens to the hundreds, that should be able to help you. But those are some things that I want you to be thinking about. All right, so on our next slide here, guys, we're going to talk more about being able to add 4/10 and 3300s, and seeing that when you add those up, that they equal 7300. We're going to use some tools here. So when we click right here on the base 10 blocks, we're going to utilize these. Okay. So what I've done is I'm going to clear out this right here, clear out the actual columns by removing the grid. I can do that. I've gone ahead and dropped and dragged 4/10 over to represent our 4/10, and I've dragged over 3300s to represent 3300s. So I've got 4/10 and I've got 3300s. So our goal is to be able to add them up. But now we got to do a simple conversion. So with our simple conversion, that means that 10 of these, so 10 of the actual units equals 1/10. And of course we got 10 right here. So let's say if we converted 10 of these, and we're going to convert them to 1 of the tenths. So we'll convert it to 1 of the tenths here. I mean, sorry, 1 of the tenths. And also, we're going to go back, we're going to get another one because there are 3 different groups of 10. So I'm going to take this one, I'm going to convert it into another tenths, and I'm going to take this third group of 10 units and I'm going to convert it to another tenths. Okay, so the only thing that I have left is going to be the actual units. So I've got 3. So now let's go ahead and add these up. So this is 1, 2, 3, 4, 5, 6, 7. So that's 7 tenths. Plus I've got 3 units left over. So 7 tenths is the same as 70. So 7 of these tenths is just like having 70 total of these. Okay, and now I've got 3 units. And of course, these are still all over hundreds because we're going to convert it to hundreds. Equals 73 hundreds. Okay. Now I could have done the opposite. I could have gone over and I could have taken all of these and turned them into ones. So if I taken all of these over here, if I turn them all into ones, it would be 10, 20, 30, 40, 50, 60, 70, and then 1, 2, 3. So that's how you can do this using the base 10 blocks. So let's discuss how to add 2 fractions with a denominator of 10 and 100. So we've already practiced. We've got a denominator of 10 right here, denominator 100. We practiced on how to use the base 10 blocks to help us. And there's a different way. There's another way that we can do it. All right, so we got 5 tenths plus 17 hundredths. Now, in order for us to be able to add these, our denominator has to be the same. So if you look at our denominators here, we've got 2 different denominators. You got the tenths right here, and you have the hundredths right here. So we want to turn the tenths into hundreds. So we want to turn the tenths into hundreds. And this is how we're going to do it. So we're asking ourselves, we've got 5 tenths right here. So how can I get from 10 right here to 100? What can I do? What can I multiply 10 by to equal 100 for the denominators? And when I think about that, I'll know that my answer is 10. If I multiply 10 times 10, that would turn that denominator into 100. Now, the thing about it is, remember, 1 tenth rod equals 10 units. So 5 tenths are going to equal 50 units. So we have to do the same thing to the top up here. So if we multiply by 10 at the bottom with the denominator, we have to do the same thing at the top with the numerator. And that becomes 50 over 100. So we've changed 5 tenths to now become 50 over 100 because they are equivalent to each other. They are equivalent to each other. So now we can effectively add those 2 fractions together because now we have 50 hundredths and 17 hundredths. And when I do that, I'm going to change it here, 17 hundredths. Remember, the denominator is going to always remain the same when you add these fractions up. That's not going to change. The only thing we have to do is add the top 2. So 50 plus 17 is 67, and that is our answer, 67 hundredths. So remember, we could not add it because initially because they had the different denominators. We needed to change the tenths to hundredths. So we needed to change the tenths to the hundredths, and we did by multiplying times 10. And remember, on our previous practice, we also changed from 4 tenths to 70 hundredths. We changed from 4 tenths, we changed that to 70 hundredths. So we did it with the models. This time we did it with the actual by multiplying by 10. So those are two ways that you can change it. All right, so on our next slide, you got independent practice. Now there's a choice for you here. You can do it on the Jamboard that's been assigned to you, or you can do it on page 33. So the Jamboard on page 33. So I'll go to the actual Jamboard, and we'll look at the first one together. So this is slide number 5. Number 1 on the Jamboard is called Fill in the Jar. And you got the first slide you got right here, then you got a second slide to complete, a third one, and the fourth one, and you got a fifth one to complete right here. Now, let's go back to the first one, and we'll look at this one together. So fill in the jar, part 1. A jar can hold 100 marbles. All right, so it can hold 100 marbles. So that's going to be just like having a 100 grid. The jar contains 3/10 blue marbles and 400 yellow marbles. All right, so you got, let's see here, 3/10 blue marbles, 400s yellow marbles. And what portion of the jar is filled with marbles? So what portion of the jar is filled with marbles? That's our question. So let's go ahead and so you got blue marble. I'm going to box in the keywords here. You got the blue ones, and you've got the yellow marbles. So I'm boxing in those. All right, so what portion of the jar is filled with marbles? Use the models and write an equation to match your model. All right, so I've gone ahead and I filled in using the 100 grids that's already provided for you. 3/10. 3/10. So this is even though this is a 100 grid, remember, because of equivalency, all I have to do is shade in 3 entire columns. So 3 entire columns out of the 10, and that shows 3/10. So 3 entire columns, I can obviously see that that's 10, 20, 30. It's going to be 30 out of 100. All right, and now I've got, and that's for the blue marbles, and for the yellow marbles, 400s. So all I needed was 4 shaded out of this entire 100s. And let's go ahead and look at an equation for that one. So when I look at an equation, I'm going to change my color here. 3/10 plus 400s. Now, I already saw that this 3/10 over here is the same as 30 hundredths. I'm going to clean this up just a little bit so I can make that better. 30 hundredths plus 4 hundredths equals 34 hundredths. So that total is 34 hundredths. And remember, right here, we used our model to convert, but for the 3/10, all I needed to do was also multiply by 10 for each. I could do that also, and I still would get my 30 hundredths for that one. So when you add them up, it is 34 hundredths. So you can use this same example when you go ahead and complete the rest of these. So you can use this example to help you to solve a model right here and for the next ones. So this is a Jamboard. Remember, you could have done it on the Jamboard or on page 33. Now there's also an additional practice here for you. So after you finish that, the Jamboard, there's more independent practice, just some games for you to practice with. And there's a math games for that first one where you can just kind of go in and practice with your adding fractions with denominators 10, 100, 1000. So start it and just spend a few minutes of practicing with the fractions. And also on the second one, it is also fraction games for you to get more practice on. And there's just some questions that we want you to answer. And you may have to do some converting. 3/10, you may have to change that to hundredths, which would be 30 hundredths. So that's your independent work for the day. And lastly, this is our last slide right here. So you complete the independent work, and also I want you to work on Dreambox.